Songs like these are actually getting popular and viral these days for some reason. We have also seen scenarios where songs from the 70s, 80s, and 90s getting viral all of a sudden in 2025. And what could be the reason behind that? There could be multiple reasons. It could be because of platforms like Instagram or TikTok where influencers are trying to create more and more reels. Or else it could be because of influencer promotion, or could be because of relatable lyrics or something. Well, can we actually predict whether a song is going to be a popular song or a viral song or not? Well, in large scale industries, in large scale companies, this could be a potential data science or an AI use case where you can actually predict whether the song will be popular or not. Well, can we replicate the same for a portfolio project? The answer is yes. In this video, we are going to talk about a song popularity prediction use case, and this is a data science end-to-end project. In case you want to do this project and write it in your portfolio, you can probably go through this video end-to-end. Now, this video is going to be explained by Advait Joshi, who is currently ongoing his BTech degree from Swami Vivekananda Institute of Technology, and he has already worked with multiple firms as a research intern. Well, his profile link will be in the description in case you want to get connected with him. Without further ado, let's get started with this project. In case you want the project codes, just write down something in the comment section. After we reach 100 likes and 50 comments, we will be sending you the codes to you. In case you have a specific requirement on any kind of project videos, let me know in the comment section because I keep an eye on this comment section. See you in the video and enjoy.
Hello everyone, today we are going to discuss my new project called Song Popularity Prediction Dashboard. It's an end-to-end data science project on music analytics. So this is our problem statement that we are going to use. That is, as a data scientist at a music streaming company, you have been given the task of understanding what makes a song popular in today's digital landscape. Your goal is to analyze a dataset containing various audio features like danceability, tempo, energy, etc., along with platform related data such as playlist present and chart appearances. The business wants you to predict whether a song is likely to become popular based on its features, identify key factors that drive high streaming numbers, provide insights that help the marketing and A&R teams to make better decisions. These insights will support playlist inclusion strategies, promotion planning across platforms, early identification of songs or artists with hit potential. So this is the problem statement, and for this project I have chosen a dataset from Kaggle. It's called the most streamed Spotify songs 2023. So the key features of this dataset are track name, artist name, released year, released month, all the playlist and charts related data, the audio features like BPM, key, mood, danceability percentage, balance percentage, etc. Also over here, the streams is going to be the output for our model for this project. So a note that the streams feature of this dataset has all the values in millions. So our model will also give us an output in millions. So if you are going to think that our model only predicts in millions and not in any other value, that's because our dataset has only millions in values. So the model cannot be trained on any other value. So that is something we need to make sure that in actual real world use cases, we do not use such data sets that does not have a range of values, because that will give us a biased or a wrong output. So let's get started with the Google Colab notebook. So this was the problem statement. So firstly, I import the libraries. We use NumPy, Pandas, Scikit-learn, Seaborn, Matplotlib. And then we import the data set from Kaggle. So now we start cleaning the data. As you can see, we have these features: track name, artist count, released year, and so on. So we understand the data types, the counts of each feature, the null values, the duplicate values, the unique values, We try to understand what is missing and what is not missing. I have added each and every understanding of mine and about what the data set is telling over here in different markdown columns. You can check these out later. Uh, Further, we analyze the dataset more of how it's structured, what is missing, what is not missing. We have object data types over here. We are going to try to convert it into a numeric type because our model usually takes in a numeric feature as an input. A few models might take object out input as well also. So make sure whichever dataset you're using, structure it properly, understand the data, select a model, and then decide which kind of uh, feature that you are going to uh, give as an input. Usually, most of the models take in the input as numeric features, so make sure you convert everything into numeric features using encoding and different strategies. So for further understanding of the dataset, I dive deep into the object type columns. You can see all the artist name, all the artist track names are going to show up over here. And as you can see, the streams numbers, mostly all of it are in millions of numbers, only one or two maybe in thousands, and one is just a messy line of all the different features after streams. So you can see BMI, you can see mode, major, danceability percentage. So this is something wrong, so we can just remove it later. So yeah, so this is the integer playlist. All of this is in numbers, but read as an object type or a string type data. That's why we'll convert this again from string type or object type data to a numeric type data. So on further analysis, I understand and drop different kinds of features. Then I encode a few features like key, major, minor to 1 and 0, and so on. So we have our final data set over here with all of the features in integer type, one as an object type, which we'll be removing again. So here feature selection. So feature selection is a very important part because this is where we decide which features to be present for the training of the model and which should not be present, or new features to be added, all of that. So over here we remove the column key because it does not make much difference having it with us for the model training. So we remove it. So as we go further, we create this data set called model df, model train df. Now we start with the exploratory data analysis part where we understand different patterns in the data set. So in this part, we are going to tackle with some questions, that is, what is the overall distribution of the target variable, that is streams? Are some musical or audio features highly related to popularity? Do certain months, keys, modes, or BPM ranges lead to more popular songs? Are there any strong correlations between features? Do platform variables actually influence popularity? So all of these questions we are going to tackle. Always make sure that when you deal with this EDA part or pattern understanding part of a data set, frame a few questions by the understanding in the data cleaning part and make sure you answer those questions using these graphs. So first we understand what does the streams distribution look like. So this is the distribution. I gave the explanation over here. The target variable streams is highly right skewed. That means a few songs have very high streams while most have lower values. This tells us that stream counts vary a lot and we may want to log transform this variable for modeling later. So like that, I have done the correlation heat map, explained it over here. We have done other plots over here. I've explained it again. So a box plot, distribution of BPM, average streams by release month. Yeah, so I have properly written everything. But again, a note for the audience. We intentionally removed complex artists or track level text features to keep project beginner friendly. Our goal was to walk through the data science life cycle in a way that's easy to understand. While we haven't applied NLP or artist popularity rankings here, these would definitely enhance insights in a production level setup. So make sure whenever you are going to actually work on a real world data set or use case, use those data that involve text or object type features and try to analyze it more, because that will actually give you a lot better outputs for your model. So again, I've given over here the business impact, then a few more understandings of the data. Yeah, so wrapping up EDA, we explored the dataset in detail through various visualizations and analysis. From EDA, we were able to understand how different musical and platform related features influence the number of streams a song gets. Based on that, we now have enough insights and clarity to move to the next step, building a model that can predict a song's popularity. Okay, so now we understood we have to make a train test split now. So now we have the data set, and now we are going to split it into train and test part. And then comes the model selection, model training part. What a data scientist should think before choosing a model. This is a very important step for a data scientist. Before randomly selecting a model, it is important to ask some key questions. That is what a data scientist actually does in real world scenarios. We should never run models blindly. So a few questions that we are going to answer is, what are we trying to do? We are trying to predict the popularity of a song by number of streams using audio features and platform related statistics. So this is clearly a regression problem, because the output streams is a continuous number and not a label like yes or no used in classification. What do we know about the data? We have around 950 rows, which is a small to medium data set. We are done with cleaning and pre-processing of the data. The data set is a mix of numeric features and a few categorical features, but we encoded them. We don't know if the data has a linear relationship or something more complex. What do we want out of the model? As a company, we should take care of two things: understanding what influences popularity, that is, we need something interpretable. We need good performance, that is, getting good predictions. What is the plan? We use three models: linear regression, random forest, and XGBoost. Yeah. We won't touch overly complex models like neural networks here, since our data set is small and the goal is clarity plus insights. So over here, we are going to see the train and evaluate part of these three models: linear regression, random forest, and the XGBoost model on the train test bed that we have done. And then we also cross validate it over here, evaluate model CV, that is cross validation. And then we see the model scores. We also then log transform. But why did we log transform? The streams column had a very wide range. That is, some songs had millions of streams, other had just a few thousand. This creates a highly skewed distribution, which can A, affect model performance, B, give more weights to high values during training, making the model biased. So we applied a log transformation to compress the range and make distributions more balanced. So once we transform it, we can see what it looks like. So 318 songs have like 18 point some streams, 545 songs have 20 point some streams, like that. And then we again check models after transform on the single train test split we did, and then we again cross validate it and understand. So what is the difference in performance before versus after log transformation? Without log transformation, we see that models were trained on raw stream numbers. The error metrics were very large in absolute numbers, in the millions or trillions, which are hard to interpret. Then random forest and XGBoost still performed well, but results were on a different scale. With log transformation, the models trained on log, so log, sorry, the models trained on log. With log transformation, the models trained on log, that is streams, so the predictions were also on in log scale. Error metrics like MAE and MSE and R square are now easier to interpret and compare. The overall performance of models became more consistent and relatable. Linear regression improved slightly in interpretability but still underperformed. So, what to use going forward? We will stick with the log transform model because it's mathematically stable, less skewed, easier optimization, helps avoid overfitting to songs with extreme stream values, gives better and interpretable scores in cross validation. So this is what we are going forward with the random forest model. The feature importance analysis. This is one of the major parts where we understand after the model training part that which feature highly was impacting the model's output. So as explained over here, now that we have trained and evaluated our models, it's important to understand which features are influencing the predictions the most. With what can we tell the marketing and A&R teams about what makes the song likely to go viral? This helps turn a black box model into something interpretable and actionable. What are we tackling here? Identify top features using random forest and XGBoost, visualize the feature importance, interpret the results in simple terms, suggest practical uses. So we plot the graph. We see that in Spotify playlists are going to be the highest importance by far. Then we have some other features. Same with the XGBoost model. We have in Spotify playlists again. So for both models, we can conclude platform presence, especially Spotify, is the strongest predictor of a song's success. Audio features are helpful but secondary. When planning promotions, focus first on playlist reach, then fine tune the song characteristics. So, the end, we successfully completed our data analysis and built multiple models to predict song popularity. Now, as the next step, we'll be shifting to modular code structure, the way a data scientist or ML engineer would do in real world scenarios. This means keeping our training logic, evaluation, and utilities in a separate clean files, making the code more reusable, readable, and easier to debug or upgrade later. The modular approach is super important when you're working on larger projects or when the same code base is used by different people in a team. After this, we will deploy our final model using Streamlit, building a clean front end where users can input song features and see the predicted popularity. We'll also include key insights from our EDA and model training phase to help internal teams like marketing and A&R make data-driven decisions. This final step is all about presenting your work like a product, not just a Jupyter notebook sitting idle. Now, I'll show you the GitHub code that I have done. So we see the Streamlit file over here. You can see the config.toml. It's just the dark theme. Now we see the images folder wherein we have all the graphs that we have got from the EDA part. So random forest feature importance, all of this. Then we have the models part wherein we are using the random forest model. Then we have the notebook wherein song popularity analysis is done. You can see in this code notebook that I have actually, wait a second. Yeah, so from here I have used joblib and imported this. I have dumped this model into a separate folder over here called random forest log model.pkl to use it for our backend in the Streamlit page. So now we have the pages section where in EDA insights.py we have model training information, we have prediction tool, and we have the project summary. And then at the last we have the homepage.py wherein all the code written for our dashboard is here. Then we have the readme file. Let's go back. Yeah, so this is the readme file. So this is how you have to present your idea or your solution for any kind of data science or machine learning project. Okay, so let's go and check out our Streamlit dashboard. So this is our Streamlit dashboard. So I've given the author details, problem statement, what we have worked on, project workflow, So we have understanding the data set, then EDA part, then model building, then evaluation, then deployment. So now let's check out the EDA insights. So as a data scientist, you have to make PPTs to make people understand about your learnings from the data set. So for the marketing team, they do not know how to read code and all of that. So make sure that you create good PPTs with detailed information for their understandings of the data and insights that you have gained. So once you check the EDA insights part, you see that we have given a proper breakdown of everything. So distribution of average streams, we have given the photo over here. And then the insight skewed distribution, the stream count distribution is heavily right skewed. Most songs have relatively low streams, but a few songs go viral and dominate. So real world pattern, this mirrors the winner takes most trend in digital platforms like Spotify, YouTube, etc. White matters for modeling. Models trained on such data can get biased by extreme values. These high stream songs may mask the general trend in the rest of the dataset. To solve this, we later applied log transform on stream counts too. Reduce skew, improve learning, focus on relative performance rather than absolute outliers. So we give the business implication, we give the marketing and A&R teams and that can focus on these particular points. So I have given all the graphs over here and then explained the insights very clearly, like what we have analyzed, key observations, and what should the A&R and marketing team do to improve our strategies for profits. Then all of these graphs are given over here. You can check these out later. So all the links to all the different notebook, the GitHub account, the dashboard, everything will be given in the description below. So make sure to check it out. So yeah, these are the plots that I've given and all of the insights. Then we go to the model training information, wherein the single train test split, we had these results. Then we did the cross validation, which had fivefold. Uh, we can see the results over here again. There is a difference between both the results. Then after log transformation, we had improved stability and reduced skew. So for the single train test split, you can check this is the outputs, and then for after the cross validation, we had this as the outputs. So that's why in the end we decided to choose the random forest model as our final model. Then the feature importance and its final observations we have given over here. Now comes the prediction tool. So what are we going to do over here? We are going to give the model the different types of predictions. For example, number of artists are 2. The in Spotify playlists is like 150 playlists. The song is in 150 playlists. Then we have in Spotify charts, let's keep it to 5. Release month, maybe October. Release day is 8. Musical key is maybe 4. That would be D, I guess. So yeah, let's keep the others basically the same. And then we click over here, predict number of streams, and we see that the estimated streams are 90 million and so. So that's what I'm talking about. The thing is, our model is trained on the values that range in millions only. So that's why our output will always be in millions. This is not an ideal data set for a robust production ready or production based uh, project. So always make sure that your data set has a proper range of data so that the model should not be biased and it should give an accurate result. So then, and in the end, we have the project summary. We have the problem statement, the methodology followed, what we did exactly, and the key learnings and insights. Then the business implications for the A&R teams and the marketing teams. So what are the next steps that I can take to improve this project, or you can take to improve this project? So that would be incorporating additional sources for richer prediction signals, experiment with ensemble models or neural networks for better accuracy. But make sure when you choose neural networks, you choose a bigger data set. Then enable bulk predictions and CSV export functionality for the dashboard part. then monitor model drift and retrain periodically and updated data. So that's the end of the project. I hope you guys liked it. This project gives us technical insights as well as the business implications that showcases how data driven analysis supports decision making. So make sure that you to try the same methodology on a different data set and try to understand the data science life cycle. So that is the entire motto of this entire project for me. I wanted to showcase the data science life cycle. So hope you guys enjoyed. So thank you, Satyajit sir, for this amazing opportunity. I hope everybody enjoyed. Bye.